Example: prove that function f r to r defined by f of x equals to x cube is 1 1 on 2. Solution: clearly domain of function equals to r. Let y belongs to r be any element such that y equals to f of x 0, which implies x0 cube equals to y, which implies x0 equals to cube root of y. As y belongs to r, so cube root of y belongs to r, because each real number has a real cube root. So f of x0 equals to x0 cube equals to cube root of y raised to power 3 equals to y. So f is onto. Next, let x1 and x2 belongs to r such that f of x1 equals to f of x2, which implies x1 cube equals to x2 cube. Equation 1. Case 1, when x2 equals to 0, then f of from 1 we have x1 cube equals to 0, which implies x1 equals to 0. So x1 equals to x2 equals to 0. Thus in this case we get f of x1 equals to f of x2, which implies x1 equals to x2. Case second, when x2 not equal to 0, then from equation 1 we have x1 cube equals to x2 cube equals to 0. x1 minus x2 into x1 square plus x1 x2 plus x2 square equals to 0, which implies x1 minus x2 equals to 0, or x1 square plus x1 x2 plus x2 square equal to 0 if x1 square plus x1 x2 plus x2 square equal to 0, which implies x1 upon x2 square plus x1 upon x2 plus 1 equal to 0, which implies x1 upon x2 equal to minus 1 plus minus square root of 1 minus 4 upon 2 equals to minus 1 plus minus iota square root 3 upon 2. But x1 and x2 belongs to r, so x1 upon x2 cannot be imaginary. So x1 square plus x1 x2 plus x2 square not equal to 0, and so the only possibly left is x1 minus x2 equal to 0, which implies x1 equals to x2. Thus f of x1 equals to f of x2, which implies x1 equal to x2. So f is 1 1, hence f is both 1 1 and onto.